Hello, my name is Gabriel Vila, and this is my application for a position as a TA at UCSD. And today I'm going to explain how to delete a node from a binary search tree. But first, let's explain what is a BST. This is basically a data structure that is optimized for searching purposes, and it has two main properties. First, every node here will have just two children at most, and it is ordered. So the elements to the right will be higher and the elements to the left will be smaller. So in this tree, for example, all of the elements and the connections in green that are to the right, they are higher, and the connections to the left are smaller. And why is this useful? So when we want to find a value, when for example, we will see how effective is using a BST. We were to use an array and a BST to find the location of the number 50. We will see that in the array, we will have to traverse through each of the elements until we find 50. And this will make us go through all of the different elements until we reach this value. So this is basically a linear complexity often. Whereas in the binary search tree, we're going to compare first with the root, which is 20. We know that 50 is higher than 20, so the element should be to the right. And now we're at 40. In 40, we see that 40 is lesser than 50, so we go to the right as well. And now we reach 50. And in every step, in the step where we went from 20 to 40, we forgot about the rest of the tree. And that's going to happen in every step. That's why this is way more efficient and is of complexity O log n. And this is important because in some companies like Facebook, Google, or others that deal with and millions of operations, when we have a complexity O log n, then we are going to use much less resources than a linear complexity algorithm. Now we're going to discuss how to delete the nodes. We have three scenarios here when we don't have children, when the node doesn't have children, when the node has one child, and when the node has two children. In the first scenario, we will just going to delete the node. In the second scenario, we are going to connect the parent and the children and the child of this node. And in the second scenario, we're going to replace this element to the minimum element to the right. We're going to see this visually now. So in the first scenario, a node having 0 children, is this case. So we're going to try to delete the node 35. And we see that this element doesn't have any children, so we just delete it, and that's our new tree. It's as easy. It's just a simple step. In the second scenario, where we have a node, in this case 30, that we want to delete, and it has one child, but what is going to happen is that we're going to connect the parent, in this case 40, and the child, which is 35. And then we are going to delete the 30. So now we have this new connection, and this is how our new tree is. So basically 30 disappeared, and now 35 has occupied its place. And last but not least, we have the deletion of this number 20, which has two children. In this case, what is going to happen is that we are going to disconnect this 20, we're going to delete it, but we are going to replace it with the minimum node to the right. In this case, this one is 30. And this 30 will come to be the new root. And now we will be in a similar position as in the previous slide. And basically we are separating 30 from here. We will connect 40 to 35, and that's how we reach this new tree. And that is basically how we delete a node from a binary search tree. Thank you very much.